we have already looked at two special types of surfaces, that of planes and spheres. Here we investigate another type of surface, cylinders. In order to sketch the graph of a surface, it's useful to determine the cross-sections of the surface. These cross-sectional curves of a surface we call traces. Specifically, traces are the curves of intersection of the surface with planes parallel to the coordinate planes. A cylinder is a surface that consists of all lines, called rulings, that are parallel to a given line and pass through a given plane curve. Of course, just reading the definition of a cylinder certainly doesn't give it justice. Sketch the graph of the following surfaces. We start with the surface z equals x squared. Notice that this equation doesn't involve y. This means that z equals x squared is true for all y values. In other words, any vertical plane with equation y equal to a number intersects the graph in a curve with equation z equals x squared. The vertical traces parallel to the xz plane are parabolas. The graph is formed by taking the parabola z equals x squared in the xz plane and moving it along the y-axis. We call this a parabolic cylinder, made up of infinitely many shifted copies of the same parabola. Here the rulings of the cylinder are parallel to the y-axis. The key to graphing this equation was realizing that the variable y was missing, in which case we just sketched the graph of z equals x squared in the xz plane and repeat it infinitely in the direction of the y-axis. This is typical of a surface whose rulings are parallel to one of the coordinate axes. If one variable, x, y, or z, is missing from the equation of a surface, then the surface is a cylinder. Now let's look at equation 2, x squared plus y squared equal to 1. When first looking at this equation, we think a circle with radius 1 centered at the origin. Although this is true in the two-dimensional case, it is certainly a different beast altogether in 3 dimensions. Since z is missing, we sketch a circle of radius 1 for all z values. So we have infinite circles sketched up and down the z-axis. Think of this as a magician's trick, where someone stands in a hoop, and the magician pulls up the hoop, which has a cloth draped around it. The surface is a circular cylinder, whose axis is the z-axis. The trace of this cylinder in the xy plane is a circle. The rulings are the vertical lines. Next, equation 3. In this case, the x is missing, and in turn, the surface is a circular cylinder whose axis is the x-axis. Here, the cross-section, or trace in the yz plane, is a circle of radius 1. The surface is created by taking the circle in the yz plane and moving it parallel to the x-axis. In general, when sketching a surface of an equation with missing variables, first sketch it as a two-dimensional curve. This will give you the trace or cross-section. Then repeat this cross-section infinitely by assuming that all the values of the missing variables are included in the graph.